Sir, do we need to wait for 1 more minute? I think it's 5:29 right now. So after 5:30, I'll start, right?
Ma'am, till then, could you please take one query?
Yes.
Ma'am, I didn't join the first day, so I have missed half of the session on YouTube, though I have attended that, but only 44-minute section is available on YouTube. Where can I access the rest of the section?
May I know who is speaking? Who is talking to me?
Ma'am, this is Jyotsna this side.
Jyotsna ma'am. Jyotsna ma'am, I think I cannot help you with this. RFI team can help you. Yogi sir, can you help Jyotsna ma'am in that? Okay. So
Thank you,
Jyotsna
thank you,
ma'am,
thank you so
probably
much.
he is sharing in WhatsApp group.
Thank you so much, ma'am.
Yeah. One more minute give me. I am just saving all the polls. Today I'm going to give you some polls after the session. Would be helpful for you to understand whatever we have learned today. Okay. Only last question I am copying and pasting in the poll. Yogi sir, can I start now? Yeah, thank you, sir. So a very good evening, everyone present over here on this online platform. Today is the day 3 of this 7 days FDP, and today I'm going to discuss reliability and the normality of data. Yes, good evening, everyone. Those who are typing in chat, I have seen everyone. Good evening. But now I'm going to share my screen, so I won't be able to see my this particular the present screen. So you need to now whatever you need to say, you need to unmute yourself for discussing and sharing with me. Okay. And 2 files I have already shared in the WhatsApp group. I hope every one of you have received those files. So what you need to do, you need to download those files, and then once I'll discuss the theoretical aspect of the concepts today, then I'll share with you the PPTs, I'll share with you the screen of SPSS. That way we will discuss or perform the things which we have learned through the theoretical aspect. So I have shared my screen. Any one of you, will you please confirm me whether the screen is visible or not? Ma'am, it is visible. Yeah, thank you so much, ma'am. Thank you, thank you. So today, as I said, I'm going to discuss normality and reliability. So starting with the agenda of the day, firstly, I'll discuss what is reliability. I'll discuss the types of reliability. Then I'll come to the normality and what are the methods we can use to check the normality of the data, right? So firstly, I'm taking reliability and we'll see what is reliability. So here, firstly, I'll discuss what is reliability. Usually, reliability is known as the measure of consistency. Give me a second. I need to check whether my WhatsApp is on or something. No, I'm getting some messages. I don't know from where. Yeah, yeah. So I was discussing about what is reliability. Reliability is nothing but it is known as the measure of consistency. Consistency means when I'm repeating a task again and again, if I'll get the same result every time, that way I can call it the consistency of the result. Or that way we can say technically that is known as the reliability. So say for example, generally when we talk about reliability, we are talking in terms of scale. Scale meaning is the normality of the data. Scale meaning is the instrument or the questionnaire, right? So whatever questionnaire we are preparing for our study to collect the data, for that scale or for that questionnaire, generally we need to check the reliability. So whether that particular scale or questionnaire is reliable or consistent or not, that we need to check using the various methods of reliability, right? So consistency meaning is, if we are using the same scale or same questionnaire again and again to conduct various studies, and if we are getting the same results every time, that way we can call that the scale is the reliable scale, or the questionnaire is a reliable questionnaire. I need to clear one thing here before proceeding further. If I say questionnaire or instrument or scale, all three are same in terms of research, right? Instrument is again a questionnaire or a scale. So scale means questionnaire or instrument. Got it? So whenever we are talking about reliability, we need to check whether our questionnaire or instrument or scale is reliable or not. Means our scale is consistent or not, that we need to check. So if we are using same scale on the different samples again and again, and every time our scale is giving us the same result, that way we can call that the scale is the reliable scale. So this is the meaning of reliability. Second question, when means when we can use reliability, or when we need to use the test when we need to test the reliability of the scale. So when we are having the questions on Likert scale, or whether we are having these questions on non-Likert scale also, in both the cases we can check the reliability of the scale. But usually most of the time when the questions are on the Likert scale, again questions or items are one in the same thing in terms of research. Okay, so whenever we are testing that whether the questions are on the Likert scale, so in that case also we can check the reliability. But as I said, most of the time whenever we are having questions on the Likert scale, in that case generally we are going for testing the reliability of the questionnaire or scale. Now, next question is where. So means where we need to use reliability. So generally, whether we are using a existing scale or whether we are using a self-structured scale, in both the cases we need to test the reliability of the scale. Question comes, why we need to check the reliability of the existing scale? Because it is already pre-tested, right? But the concern is that if we are using the existing scale for our research purpose, so in that case also we need to check the reliability. Reason being, because it is quite clear that the scale is previously developed, the time frame would be different, right? So maybe with the period of time, maybe some changes can occur, and maybe those changes are not incorporated in the scale. So might be possible that your scale cannot be reliable according to the present time. So for the purpose, you need to check the reliability. Also, whosoever have developed that particular scale, maybe they have conducted various types of pilot study on a particular region, in a particular area. So for the purpose also we need to check the reliability, because might be possible we are not conducting our study in the same region or in the same area. So for the purpose again might be possible that when we are conducting our study in some other region, so maybe the scale is not reliable on that particular region. So again, for the sake of testing that scale is reliable or not in the different region, again you need to check the reliability of the scale, right? So that way, these are the some of the reasons. If you are using existing scale, in that case you always need to check the reliability. Next, if I'm talking about the self-structured scale, say for example, if I'm making a new scale for testing any particular construct, right? Say for example, now I want to maybe I want to check the anxieties in the suppose employees. What is the anxiety level of the employees? So for checking the anxiety level, it might be possible there are certain skills already available, but with our own sense, with our own literature review, if I want to develop a new skill for the anxiety or in the employees, so again I can develop that skill, I can make that skill. But before proceeding for the research purpose, you need to always check the reliability, that whether your skill is reliable or not. If it would be reliable, that means it is a green signal for you, you can go ahead for the research. So this way, this is the answer of where in context to the reliability. Lastly, last question is how. how we can test the reliability. So answer is very simple. Using various methods of reliability, we can check the reliability, right? So this way, these are the 4 different questions for the reliability. If we are getting the answers of that way it is very easier for us to understand the reliability. Now I'll discuss the types of reliability first, and then we will move for the methods of reliability. So usually we can divide reliability into the 2 parameters, stability and the internal consistency. So on the basis of these 2 things, we can divide reliability. So whether your scale is stable or internally consistent or not, that you need to check. Now talking about methods of reliability. So we can divide methods of reliability into the 4 different segments. The first is test reliability, and second one is the parallel form reliability. So when we are talking about stability, when we want to check whether the scale is stable or not, in that case we can check test and retest reliability of the scale, or also we can check parallel form reliability of the scale. If we want to check internal consistency of the scale, in that case, fourth reliability is available. Split half reliability is also available to check the reliability of the scale. So that way, these are the 4 various methods, different methods available. Using that, we can check the reliability of the scale. Now we will see all 4 methods one by one. So firstly, I'll discuss test, retest reliability. So in this slide, I have written so many theoretical concepts about the test, retest reliability. Using this particular theoretical aspect, I tried to make a diagram for you all. Maybe this will help us to understand this reliability in an easier way, right? So here you can see what I did. In the theoretical part, it is written that we need to administer a test. Test meaning, suppose I have a quiz or I have a questionnaire available with me. So what I'll do, I will divide my group. What I'll do, I will give that particular questionnaire to the respondent firstly. Say for example, today I have given one questionnaire to my respondents, right? So a group of respondents were provided with a questionnaire. So they are giving their responses to that particular questionnaire, and I am storing or scoring their records, right? Now, after a sufficient period of time, I will repeat the same test or same questionnaire on the same group of respondents. So the gap or the time period, we can say it can be 2 months, 3 months, or maximum it can be 6 months time gap between these 2 conducts, right? So here you need to understand this thing. The group of respondents would be same at both the time. Questionnaire would also be same, only the difference, there would be some time difference would be there between these 2 conducts, right? Every time we will collect the score of the respondents, and then in those scores we will apply coefficient of correlation. And if coefficient of correlation value is coming more than 0.7, in that case we can say this thing, or we can conclude this thing, that our scale is the reliable or the stable scale according to test retest reliability. So I hope it is clear.
Yes, ma'am.
Yeah, thank you so much, ma'am, for confirming. Coming to the next section or next type of method, that is the parallel forms reliability. So in the parallel forms reliability also, I tried to make a diagram for you. You can see here. Now this time what we will do. So here in the parallel form reliability, we will divide our test or our questionnaire into the 2 parts. Say for example, in a questionnaire, suppose there are total 50 questions available. So what I can do, I can keep first 25 question in the first part, next 25 question in the second part, or I can take all the odd number question in the first part and all even number question in the second part. Any way I can arrange my test, or I can arrange my questionnaire. Only I need to divide or split it into the 2 parts, right? Then what I'll do, I'll give the first part to some group of or some respondents. I will give the first part, and then after a short time frame, means the duration would be little less, and then I'll give the second part of the questionnaire to the same group of respondents, right? So that way, both the times I'll collect the scores of the respondents on the first part and on the second part, and that way I will calculate the coefficient of correlation between these scores. And if again the score is coming as greater than 0.7, In that case, we can say this thing that our scale is the stable scale according to parallel form reliability. Is it okay? Is it clear to everyone? May I proceed?
Yes, ma'am.
Yeah, thank you. Coming to the third part, that is the split half reliability method. So in this, what we will do, here you can see, rather than dividing our questionnaire into two categories, we will split the respondents into the two groups. So suppose I am targeting that I need to fulfill this particular or this questionnaire. I need to get it filled by the suppose 100 respondents. So I can what I will do, I'll divide them into the 50-50 group. So that is 50 would be in first group, 50 would be in the second group. And at the same time, I will give the questionnaire to both the groups. And at the same time, I will also record their scores. And then in the scores, I will calculate the coefficient of correlation. And if suppose this coefficient of correlation is coming as 0.7 or greater than 0.7, so I will say this thing that the scale is reliable as per the split half reliability. So far, am I clear for all the three methods? Is it okay? May I proceed? Yeah, thank you. Coming to the last method of the reliability, named as internal consistency reliability. And it is a very important method to understand reliability, because nowadays most of the people are using this particular reliability only. And when I talk about the SPSS, by default method is available for the internal consistency checking of the scale, right? So I'll explain you the meaning of internal consistency here. So internal consistency meaning is the degree of homogeneity of items on a particular scale. So scale means, again I said, it's a questionnaire. So say for example, in my questionnaire, suppose there are 20 questions available. So the question should be, it is not like they should be almost identical, but somewhere they should be related to each other. They should be internally consistent. Somewhere they need to be linked with each other. So that way we can achieve the internal consistency. So it tells us about up to what extent a test is internally consistent, or up to what extent there is a good amount of balance of correlation between the items or indicators. So to explain you this in a better way, in the next slide, I have taken the example of motivation, right? So say for example, I want to check the motivation level of my research scholars, whether my research scholars are motivated towards pursuing PhD or not. So for checking that, suppose I have made a questionnaire. In that there are total 10 items available. You can see here x1, x2, x3 up to x10. So suppose we are having total 10 questions to measure the motivation. As we all know that motivation is a kind of qualitative phenomena. We cannot directly calculate or measure the motivation in any particular person, right? I cannot say, means by looking at me, maybe suppose you are looking at me as my video is on, you can see my posture, you can see why I'm talking to all of you. So you can say at looking me, you cannot tell me what is the motivation level of mine, right? It is not easier for any of us to say this thing by looking at a person. And even there is no apparatus or instrument available through that I can measure the motivation. So as we are knowing, motivation is a qualitative phenomena. This is a kind of term which we cannot measure directly. So that is why we can call this term as a latent variable. Latent variable means which we cannot directly measure. Okay. So that is known as the latent variable. Or other name for latent variable is also known as construct. Usually in factor analysis, most of you have heard this term construct. So once we are talking about the factor analysis, maybe you people have heard about this construct, right? So the construct or latent variable we cannot directly measure. And if we want to measure that, we need to take the help of some other things. So here in research, what we take the help of certain questions or statements, right? So say for example, if I want to measure the motivation level of the research scholar, so suppose my first statement is, I like to pursue research, or I find research very interesting. That can be my first statement, right? So that way, all the statements which I am going to put in my scale, they should be somewhere related to this kind of thing. That way, maybe I can assess or measure the motivation level of my research scholars, right? So you can understand, if whatever number of items I have kept on a particular scale to measure motivation, it will tell us that if these items are fairly correlated to each other. Fairly correlated meaning is there should be approximate a moderate level of correlation among all the items which I have kept to measure a latent variable. In that case, I can say this thing, that the scale is internally consistent. I hope it is clear to everyone. Was it little okay or not?
Can you explain the
Sorry?
last statement which you made?
Clear, ma'am.
Okay, one person said, I think clear. One has asked me certain question. Will you please repeat the question?
Ma'am, can you please repeat the last statement which you made about consistency?
Okay, I'll try, because I forgot why I just said. I tried to repeat it again. Okay.
Yeah.
I said this thing, whatever the number of items we have taken on a scale to measure the underlying construct, if they are fairly correlated to each other, in that case we can say that the scale is internally consistent, right?
Yes.
Means
Yes.
if there are moderate level of correlation among all the items on a scale which we have taken to measure the latent variable, so we can ascertain that thing, that the scale is internally consistent.
Yes,
Is
ma'am.
it fine?
Yes, ma'am. Thank you.
Yeah, thank you, sir. So this way we can understand the terminology internal consistency, right? Now, I hope, am I clear to everyone? May I switch to the next slide?
Yes.
Yeah. Yeah, thank you, everyone. So coming to the next slide, here you can say that by using internal consistency reliability, one can find out up to what extent test score and true score are closer to each other. Now, we need to understand that how we can measure the internal consistency in any of the software. Usually, there is a terminology you all have heard about, that is the Cronbach's alpha. So using Cronbach's alpha, we can measure the internal consistency of the scale. So this Cronbach alpha is widely used by almost everyone of us in the research field to check the internal consistency of the scale. And mostly those who are going for the factor analysis, mostly they are knowing this thing, that before performing factor analysis, generally we need to check whether the scale is reliable or not. So generally we are applying the Cronbach's alpha. Fine. Is it okay? Is it okay?
Yes, ma'am.
Yeah. Now coming to the next slide, it is saying to us that there was a American psychologist with the name Lee Cronbach. He has given this Cronbach's alpha in the year 1951. So after his name, he has given the name of this coefficient as Cronbach's alpha. So it helps us to measure the internal consistency or inter-item reliability among the items on a particular scale. So using the coefficient of correlation, generally correlation is used here to tell you the reliability of the scale, right? So it's a coefficient which gives us the measure of internal consistency of the test. Now you need to see this red highlighted portion here, that is, by internal consistency we mean to what extent indicators of the test are related to each other, right? Now the last point is very essential to for every one of you here. You can see whether the items, that is questions, so whether the questions are continuous or on dichotomous scale. Also means the meaning of this is that items can be either on the Likert scale or they can be either on the non-Likert scale also. In both the cases, we can apply the Cronbach's alpha on the data which we are collecting through the continuous scale, or whether we are collecting through the dichotomous scale. I hope, am I clear? May I switch to the next slide?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. Now coming to, although I have taken this particular slide intentionally here to let you know that there is a formula, because every software which is designed by the experts, they all are based on certain formulae, right? So here you can see for Cronbach alpha, there are two approaches to calculate Cronbach alpha. First is the variance method and second is the correlation method. So for variance method, this is the formula, and for the correlation method, this is the formula. Usually, using the when I talk about the software SPSS, so in that generally the formula which we are looking of the values which we are getting through the SPSS, it is based on this particular formula, that is the correlation method formula. Now, coming to the interpretation part of Cronbach alpha, it is very important for every one of you to understand. So please understand it patiently and try to make a note if you are writing in your copies or in your notebooks, right? So here I am reading this table from the bottom. If alpha value is less than 0.5, in that case, interpretation is unacceptable reliability of the scale. If alpha lies in between 0.5 to 0.6, we can call this as a poor reliability. Alpha is falling in between 0.6 to 0.7, it is a questionable reliability. Alpha is falling in between 0.7 to 0.8, it is acceptable reliability. 0.8 to 0.9 alpha value is a good reliability, and if alpha value is greater than 0.9, it is excellent reliability. But here again there is a problem if your alpha is coming greater than 0.9. And what is the problem? That I'll explain you in the next slide. I hope it is okay. Yahan tak everyone is okay. Everyone is getting me. Meanings
Yes,
are clear,
ma'am.
right? So now when alpha value is coming greater than 0.9, in that case it is known as the multicollinearity in the data. You can see here I am rotating my mouse, the term is written here, it is known as multicollinearity in the data. That means it is clearly indicating that your questions or items on your scale are almost identical, right? Because I think those who are from the statistics background or from the mathematics background, they can do such kind of experiments, right? Even I think anyone can do. I'm trying to explain you. You can put, suppose you have opened a Excel file, suppose, right? Now you have entered a number 1, 2, 3, 4, 5 in one column, and in the second column also you have kept the number 1, 2, 3, 4, 5. Now you can, using the Excel, you can calculate the Cronbach, you can calculate the correlation between these two series. In both the series, items are identical. Okay, so once you will apply Cronbach alpha on such correlation on such data, it will give you the value as 1. That is perfectly correlated data. So it is quite clear when we are calculating or measuring correlation in the two identical series, we will get the perfect correlation, that is 1. So that is why if your alpha value is coming greater than 0.9, it is indicating you that your items are very much identical in nature, or maybe respondents are taking them as a same. So what you need to do, you need to sit, you need to check your items, and then you need to check what is the problem with the items. In that case, you can rephrase them, or you can meet to some expert of the field, and then you can talk what type of changes you need to make in your scale. So that is why most of the people, those who are performing or those who are want to pursue their PhD, or those who are writing their thesis, once they are collecting the data, generally you have heard about the term pilot study, right? So usually people are going for the pilot study. They are conducting, or they are administering their scale on a small set of people, maybe 30 or 50, and then they check the reliability of the scale, right? So that way they are getting what type of reliability measurement they are getting. Alpha values coming as 0.7, 0.6, 0.8, 0.9, or more than that. So that way they are getting an understanding whether the scale is okay or not. And that way, if they are satisfied with the Cronbach alpha value, then they proceed further for the collection of the full sample size, right? So this way, this is the important term, or what I can say, the concept about the Cronbach alpha. So I hope, am I clear on this slide? Is it fine?
Yes, ma'am.
Yeah, thank you. Coming to the next slide, you can see that how you can perform Cronbach's alpha in SPSS. So this is not I am reading here. I'll show you once we will go to the SPSS. So this is all I have discussed. Now, very important thing. Can we change or can we improve our reliability coefficient? Answer is yes. How you can improve your reliability coefficient? So what you need to see, there are three things which can help you out to improve your reliability coefficient, that is Cronbach alpha value. The very first thing is you need to diagnose the missing values in the data. Sometimes it happens we are having a large sample size, right? Might be possible in a hurry you have not paid attention on the data which you are having. If some missing values is available in the data, because nowadays usually what we can do, we can collect the data through the Google form. In the Google form, generally what we do, we make each and every question compulsory, right? So when we activate that you need to compulsory answer for that particular question, usually people give answers to you. But when you are collecting data from the field, means directly you are visiting or to the people, directly you are going physically to them and asking them to give their responses to your questionnaire. So in some cases it might be possible that some people are maybe willingly, they do not means intentionally they do not want to give you answer for certain questions, or maybe they are hesitant in giving the answers of certain questions. So maybe they can skip your questions. So that way, that particular thing will become the missing value for you. So you need to diagnose properly what type of data you are having, whether for each and every column, each and every row data is available with you or not. If some missing value is available, you can take a chance to drop that particular question, or sorry, not question, that particular respondent's response. You can delete that row. Got it? So that way might be that your Cronbach alpha can be improved. Second way, you can check or you can diagnose the item total correlation. So once I'll let you through the SPSS, I'll show you in the output, you will get one more table apart from Cronbach alpha table. There you can check the item total correlation. So this item total correlation is very important parameter. It is again helping you out to check that how you can improve your Cronbach alpha. So for the purpose, I have taken the next slide. Next thing is how you can improve the reliability coefficient. So now you need to check. This is just you can check by your own. After reading your questions, you can understand whether there is some ambiguity in the questions, some items are redundant in nature or something like that. In that case, carefully you need to go through your questions, your questionnaire, and that way, or either you can meet to the expert of that field. So they can help you out. Might be possible you have written a particular item or a question in your sense. Maybe the other people or the respondents are not taking in that in the same sense. So might be possible they are giving you the responses according to their sense, and it is not meeting your criteria, right? So that way you need to check the ambiguity and redundancy of the items on the scale, and that way you can improve your reliability coefficient. Now, how you can diagnose the item total correlation? So usually the item total correlation should be greater than, or it should be equal to 0.3. It should be the minimum item total correlation which is permitted. But in some cases 0.2 is also considerable. But apart from that, also one more thing is that if item total correlation is coming as negative, so in that case also we can drop the items in which the item total correlation is most negative. So firstly you need to drop a most negative item, and then means then in the particular ascending order you can move ahead, you can drop the items, and that way maybe your Cronbach alpha can be improved. But again, here one more thing I need to bring in your notice. Being a facilitator for this FDP, I need to tell you this thing, that again this would be a totally researcher's call. There would be, because we here is the owner of our research, right? So this is we who decide whether how many questions I need to remove from my study. There would be no one to tell you remove 10 questions, 20 questions, 30 questions, something like that. This is we who will take a call that I want to drop 5 questions, 3 questions or 2 questions, because answerable will be us only, right? So this would be totally our call, how many questions we are removing from the scale and why we are removing those questions from the scale. So that way, using all these methods, we can improve the convex alpha. Next in the slide is the normality. But before discussing the normality, I'll take you through the SPSS, and then we will see that how we can check the reliability of the data. So give me a second. I'm going to share the SPSS window with all of you, and I expect all of you to open the first sheet in the SPSS with the name customer satisfaction, I think. Right? I think I have given this same sheet to all of you. Right?
Yes, ma'am.
Yeah. So I expect all of you to please open the first Excel file with the name customer satisfaction towards restaurants. I think I forgot to share my screen. Give me a second. Okay. Okay, my screen is visible. I have shared. Yes.
No, ma'am.
No, ma'am.
Acha, just a minute. Give me a second. Okay, it is showing me I am presenting. I don't know why. Oh, I forgot to just a minute. Yeah, I forgot to select the window. Yeah, it is now visible.
Yes, ma'am.
Yes. So I expect every one of you to open the same sheet, and if you have opened it, please give me a signal so that I can start with the presentation part. You can tell me if you are ready with the file. Everyone, are you okay? Ready with the file?
Yes, ma'am.
Okay, so shall I start?
Yes, ma'am.
Okay. So now what you need to do, firstly, we need to check the reliability. For checking the reliability, I suggest everyone go to the analyze menu, then come to the scale, and then go to the reliability analysis. Again, I'll repeat, go to the analyze menu, then go to the scale, and then select reliability analysis. Is it fine? May I click on reliability analysis?
Yes, ma'am.
Yes, ma'am.
Yeah, yes. So I have done the okay on the box, and now I am on the reliability analysis box. Now what you need to do, all the items which we have taken, all the items are on the Likert scale. Sorry. Now what? Sorry. Now what I need to do? I need to select all the items and need to shift to the right box with the name items. Right. So I am selecting all my items using Control A from the keyboard, shifting these questions using this arrow key into the next box. Done. I think shifting is done. Everyone. Am I audible?
Yes, ma'am.
Yes, ma'am.
Ma'am.
Okay. So if shifting is done, now what you need to do in the statistics under this descriptives for, you need to check item, scale, scale if item deleted. All three we need to check. Done. Then you can press continue. Is it fine? May I?
Yes, ma'am.
Yeah.
Excuse me, ma'am. Your voice.
I think someone has forgot to mute himself or herself. You please need to check, everyone. Yeah. I think now again I'm repeating what I said. all the items, those were listed in the left hand side, we have shifted them using this arrow key into the right hand box, right? After that, you need to go to the statistics button. Here under the descriptives for, you need to check item, scale, scale if item deleted. Only these three things you need to check here. And then you can press continue. After that, you can see here under the model, by default alpha, that is Cronbach's alpha method is available there, right? So we are okay with alpha because we want to check the customer satisfaction. Customer satisfaction would be our latent variable. So for measuring that, we have taken certain items. So that is why I want to check whether the items are internally correlated or not, internally consistent or not. So I'll go with the alpha. And then I am pressing here OK. So I think, may I?
Yes,
Is
ma'am.
it? Yes. Once I have pressed OK, you can check here, we are getting here the results. The first section or the first table is stating us that total or the valid cases, it is 121, excluded is 0. That means there is no missing value in the data, right? So that is why whatever is the valid, it's coming as a total. So that is total 100% data we are having. Coming to the reliability statistics, second table, you can find here Cronbach's alpha value is coming as 0.672 for total 31 items, right? So 0.672 is not a acceptable value. It's a questionable. It's a poor reliability value, right? So that means we cannot go with this reliability. So what we need to do now, we need to check, can we improve this? So answer is yes. But how we can improve this? I'll explain you one by one. So firstly, after understanding the Cronbach's alpha value meaning, we are coming to the next table, that is item statistics. I think till table number 2, am I clear to everyone? May I proceed?
Yes, ma'am.
Yes.
Yes. Now in the item statistics, you can check for all the items which we are having on a particular scale. You can check this is the mean value, this is the standard deviation value, and these are the total responses for each and every item, right? So now if I talk about the mean value, so for the modern equipment, maybe we are talking about a particular restaurant. Say for example, any restaurant in Indore city, because I am belonging to Indore. So suppose I have collected the data from the Indore city for a particular restaurant. So suppose I have asked from the customer whether they are satisfied with the modern equipment available in the restaurant or not. So that way, this is a 5-point Likert scale question. So in a 5-point Likert scale, I have given them strongly satisfied, satisfied, then neutral, dissatisfied, and strongly dissatisfied. So generally, when we are going for the coding, so we are giving 5 to the strongly satisfied. So that way, 2 would be the dissatisfied. So this 1.49 is approximate dissatisfied or strongly dissatisfied. We can say 1 is for strongly dissatisfied, 2 is for the dissatisfied. So it is in between 1 and 2. So that way we can say maybe the customers, those who are visiting that restaurant, they are not finding that there are some modern equipment available in that restaurant. So that way you can see this particular mean value, right? Coming to the next portion of the output, that is item total statistics. So here I'll explain you all the columns one by one. I hope am I clear till last table? May I explain this?
Yes,
Yeah. You can see first is scale mean if item deleted, meaning if I will delete this modern equipment question or item from my scale, so that way the mean total mean of the scale would be 96.74. Likewise, if I'll delete any of the mentioned questions, this would be the total mean of the scale. Similarly, scale variance if item deleted. So if I'll delete question number 1 based on the modern equipment, so the scale variance would reach to the 147.242. And likewise, you can read for the other items also. The most important column is this column number 3, which I'll explain you afterwards. Before taking the question, column number 3, firstly I'll take the column number 4. So column number 4 is saying Cronbach alpha if item deleted. So that means if I'll delete any of the item or question from my scale, what would be the impact on Cronbach's alpha? So if I'll delete the first question, my Cronbach alpha would be 0.675. Presently, it is what? It is 0.672. So if I will delete question number 1, my Cronbach alpha will come to the 0.675. Similarly, if I'll delete question number 2, it would be 0.674. So you can check, you can scroll down, you can check what is the highest figure we are getting for the Cronbach alpha. So you can find here it is, I think, 0.689 according to me. Maybe if you are applying, you can check at your end also. According to me, it is, I think, 0.689. So if I will delete the question, attentive attitude from my scale, in that case, my Cronbach alpha reached to the 0.689. But any of the items, if I am removing, you can find here, anyway, we are not reaching to 0.7 because 0.7 is the acceptable value of Cronbach alpha. So now what we can do? Now we can come to the column number 3. Column number 3 is talking about corrected item total correlations. You can recall the slide I have just discussed. In that we were talking about the item total correlation. So I told you in that, firstly, what you need to do, you need to go, you need to scroll down, you need to check for all the item total correlation, whether any of the item total correlation is negative or not. If yes, so firstly, we will remove that item, right? So I'm scrolling down. If you are, if you have also performed, so you can also check at your end whether we are getting any negative correlation value or not. Yes. Yeah, I think we are getting here.
Yes.
For attentive attitude and for personalized service. These two figures we are getting. So firstly, we need to pick the most negative value here. So the most negative value would be minus 0.110. Okay, fine. Am I clear?
And please, can you repeat this corrected item?
Total item correlation.
Yes, ma'am.
Okay. So for item total correlation, what we need to do, we need to go to the particular column and we need to scroll till the last column, right? Now you need to check whether we are having any of the negative item correlation available for any of the items or not. So here I am scrolling down and I think we have found here that for the 2 items we are getting negative item total correlation. It is for attentive attitude we are getting minus 0.110 and for personalized services also we are getting minus 0.102. Is it okay?
Yes, ma'am.
Yeah. Now what you need to do, you need to check which one is the most negative figure.
Oh, yes, ma'am. 1101.
Right? So this one is the most negative. So what we will do, we will remove this attentive attitude. Fine?
Okay, ma'am.
Yeah. So what I'm doing, I'm going here and I'm again accessing this reliability analysis from here. Now I need to check attentive attitude, where it is lying. Am I getting it or not?
Yes, ma'am. Question 23.
Question 23, yes. Yeah. Now what you need to do, you need to shift this item from here to the box at the left hand side. You can send it back to the left hand side box. That way, if you are again performing this particular reliability analysis, it will not consider this particular question. Or we can do one more thing, we can remove both the question. Suppose I am shifting both the question at the left hand side, which were having the most or which were having the negative item total correlation. Is it fine?
Yes, ma'am.
Now I'm pressing OK to generate the output. Oh, I got it or not again?
Yes, ma'am. 0.7.
Yeah, now this time it is coming as 0.701, right? So I think this is a kind of magic we have seen. Maybe I don't know how many of you are knowing this thing. So this way we can improve the Cronbach alpha. And now, as you can see, previously we were having total 31 items or questions on a particular scale. Now we were having only 29 items. So this would be totally a call of a particular researcher with how many questions he want to go ahead with the research study, right? So that would be total your call. If you are pursuing any particular research study, in that case, your guide will let you know all these things likewise, right? So this is what you need to see, right?
Yes, sir.
So I hope the reliability analysis is clear to everyone. May I proceed with the next part?
Yes, ma'am.
Yes, ma'am.
Okay. So now I'm sharing the slides. Anyone, will you please confirm me slides are visible or not?
Yes, ma'am.
Yes,
Yes,
ma'am.
Visible. Okay, thank you so much. So now when I come to this normality, usually I think many of us are knowing this thing, that what is reliable, what is normality. Generally normality is nothing but this is the normal distribution of the data. So those who are good in statistics, they are knowing the normal distribution. There are certain characteristics of normal distribution. So the one important characteristics is generally, whatever I'm saying, please listen it carefully. Might be this question can be in your pool, right? So, for example, generally, if I say normal distribution, so for perfect normal distribution, mean, median, and mode, all three should be same. If I'm talking about the perfect normal distribution, if mean, median, and mode, all three are coming as the same value, so we can call that our data is perfectly normally distributed data. Similarly, if I talk about the mean value, so generally for the perfectly normally distributed data, here you can read it. Possibly, I think I have mentioned in the slide, you can read it. For normally distributed data, the mean should be 0 and standard deviation should be 1. But this is the case of perfect normal distribution. Usually in the real world, it is very hard to get a perfectly normally distributed data, because if suppose I have I have made a questionnaire on a Likert scale, right? And my Likert scale is 5-point Likert scale, right? So maybe I have given 1, 2, 3, 4, 5 as a kid, as a coding to my 5 points or 5 options of the Likert scale. So once I'll go for calculating the mean value for a particular item, it is quite clear I will never get a 0 value, because I have coded my data as my 1, 2, 3, 4, 5, right? Is it okay? Clear to all?
Yes, ma'am.
So whatever, so that is why I said this thing, for the real world it is very hard to get a perfectly normally distributed data. So we need to somewhere do the adjustment with the normality. So we need to have, means what should be the acceptance values of these things, so that we will discuss, right? So generally, when we talk about normality, we all have seen, I think, that the normal distribution curve, this is generally symmetric and bell-shaped curve. So whatever data we are having, that we will plot on a graph, we will keep a normal or the well-shaped curve on that data. If all the data points will come under that particular curve, we will call that data is normally distributed. But if data points are lying or exceeding that particular normal distribution curve, well-shaped curve, so in that case, this is hard to say that data is normally distributed. Maybe you have seen the normal distribution or the bell-shaped curve, so you are knowing there are two tails available, right tail and sorry, left tail and right tail. So that is all we will discuss in the upcoming days, what is these things and what is the one tail and two tail, right? So that we will discuss in the upcoming sessions. Coming to the next, as I said, there are certain characteristics or features of normal distribution. One, I have told you, mean, median, and mode should be equal. Second is, generally mean should be 0 and standard deviation should be 1, and skewness should be 0 and kurtosis also should be 0 for the perfect normal distribution, right? But as I said, in the real world, it is hard to get such kind of data. So in that case, what is the acceptable values? So for skewness and kurtosis, if you are very much rigid about the normality, you can keep as ±2 for skewness and kurtosis. But if you are little lenient about the normality, you can keep it as ±3 also. So means if your skewness value is falling in between ±2 or -2 to +2, in that case you can call that your data is approximately normally distributed, right? Similarly, in case of kurtosis also. Now you can see these are the three things I have taken here to explain you normality. This is the bell-shaped curve. For bell-shaped curve, mean, median, mode, usually all three are equal. Usually all three fall at the middle of this particular curve. That means there is no skewness we are finding. Skewness means a study of the asymmetry in the data, right? So when you will look at the right-hand graph of the particular slide, you can see this is the skewed data. And in skewed data, you can find it is a positively skewed data when your right tail is greater than your left tail. This is known as the positively skewed data. And in positively skewed data, usually mean is greater than median and median is greater than mode. In the negatively skewed data, at the left graph I am talking about, you need to look at the left graph. So here the left tail is greater than to the right tail. So that way this is the negatively skewed data or left skewed data. In this case, usually your mode is greater than median and median is greater than mean. So that means mean would be very less in your data in comparison to median and mode. So that way it is known as negatively skewed data. So using these three figures, you can understand whether your data is normally distributed or not. Now, how we can check normality? Usually there are two methods, numerical methods and the graphical methods. Using these two methods, we can check the normality of the data. When I talk about the numerical methods, under the numerical methods, we can keep skewness, kurtosis. Also, we can keep Kolmogorov-Smirnov test and the Shapiro-Wilks test. So all these I'll show you in the SPSS. When we talk about the graphical method, using the histogram, box plot, and QQ plot. Usually PP plot also we can keep. PP means percentile, probability plot. PP plot means probability plot. QQ means quantile plot. So when using all these 3-4 plots, we can also check whether the data is normally distributed or not. Now, talking about the histogram, I think many of us have seen the histogram. Histograms are nothing but it is a kind of bar types of representation of the data. And generally for the continuous, that is the numeric variable, we are using the histogram. So you can see there can be a various kind of histogram we can get usually with the help of data. So if your data is like this, it is showing your data is skewed data. It is skewed to right side. It is positively skewed data, because here once if I'll keep a bell-shaped curve on this particular graph, you can assume I'm trying to draw that. So that way you can see it is showing your right tail is greater than your left tail. It would be a positively skewed data. If your data is showing such kind of distribution, that way you can see there are two peaks, two similar type, two peaks, 2 points or 2 bars are very high. So that way this is a double peaked data. That means there would be possibly two mode available in the data, right? If I'm getting a data like this, or the distribution of a data like this, it is showing us this is a bell-shaped curve, or we can say this is an approximate normally distributed data. This is clearly a positively skewed data, and this type of distribution of the data is showing we cannot comment anything on the normality of the data, because there is no proper pattern we can identify in this particular distribution of the data. Now, I think this is what we will discuss in the SPSS. QQ plot, you can see sometimes maybe those who have applied the various types of tests using SPSS, they have seen they are getting usually QQ plot when we go to check the normality. So if your data is normally distributed, I'm talking about the very first graph of this particular slide. You need to see at the top at the top of left of the particular slide. So at the top left side, I'm rotating my mouse. You can see this is known as the perfectly normally distributed data, because here whatever is the fitted line, all the data points are falling across that line, right? So this is normally distributed data. Generally, in the technical term, we can call such type of data as mesokurtic data, right? Now this is which you can see data points are deviating from the fitted line. So that way this is known as left skewed data. When your data is going upward, some points are going at upward. So this is the left skewed data. Points are coming at the downward. This is known as the rightly skewed data. Now, when you can see when more points are coming here, right? And in that case, we can call the tails are thick. Then this is showing that the tails are thin. So generally, this is suggestive from my point of view to all of you. It is little what I can say tricky to usually assess or say something about the normality using the various plots. So that is why generally most of the people reporting to the numerical methods or reporting normality using the numerical methods, because using the p values or using the figures, I think it is a little easier for us to say something about the normality. So this would be totally your call, which type of method you want to use for assessing the normality of your data, right? Now talking about the box plot, this is a very important aspect of any particular study, because apart from your normality, box plot will tell you one more thing, that is the outliers in your data. So firstly, I'll explain you what are the component of the box plots, right? So you can see here, if I talk about box plot, there would be total 5 components. So you can see, and this is the green box. In the green box, you can find a line is coming at the middle, right? So this middle line is what? This is indicating the median value of your data, right? Now the upper line of the box is indicating third quartile, lower line of the box is indicating first quartile. This particular dotted line here, you can see this is the lower whisker and this is known as the upper whisker, right? And these circles which you can see, which is exceeding the whiskers at both the sides, these are known as the outliers in the data. Now, how to check outliers? You can see the formula I have written here. Using this formula, usually people can calculate the outliers also. So that way, these are the 5 components available in the box plot. Now, talking about the skewness, although I have already talked about the skewness, I have told you this thing. Skewness is the measure of asymmetry in the data. There can be 3 types of skewness. Positive means there can be 2 types of skewness: positive skewness or the negative skewness. Or else, if there is no skewness, we can call this type of data as the normally distributed data, right? Positively skewed data means when your mean value is greater than median, median is greater than mode, or when looking at the graph, when you can see when the right tail is greater than left tail, this is positively skewed data. When your left tail is greater than right tail, this is known as the negatively skewed data. Or when your mean is less than median and median is less than mode. So this way, this is known as the skewness of your data. Talking about the kurtosis, kurtosis can be of 3 types. It can be mesokurtic, leptokurtic, and platykurtic. Now you can see in the graph, all 3 types I have tried to represent here. The middle black one is showing you the normal distribution curve. This is known as the mesokurtic data. If your data is perfectly normally distributed, you can call it as a mesokurtic data. If your graph is coming very flat type of graph you are getting, so this is known as platykurtic, means there is a negative skewness available, right? When the peak means there can be 2 things in the study of kurtosis: the study of the peakness of your curve and the study of your tails, right? So the peak, when the peak is very sharp, very sharp peak you are getting, that is known as the leptokurtic data. That means there is a positive skewness in the data, right? So in case of positive value, we can say this thing, that the tails are very heavy. You can see here when you will look at the blue graph, you can find the curve is very means the peak is under this particular shape, whatever you can see, this particular, this is very sharp peak, and also you can see the tail. These tails are thick, means there are more data points are falling on the tails. So that way, this is the positive kurtosis or the leptokurtic data. This is in case of the negative kurtosis data, you can find that the tails would be lighter, means there would be a less data fall will fall on the tails, and most of the data would be at the middle, and that way it can call it as a platykurtic data or negative kurtosis data. This can be known as. So this way, these are all about the normal distribution or the normality of the data. So this way you can understand normality of your data. Now I'll take you through the SPSS to explain you the next thing, that is the normality of the data. For the purpose, I expect everyone to open the next data set which I have given to you with the name bank loan. Right? I have given, right?
Yes, ma'am.
Yeah. So I expect everyone to please open it. Okay, so may I start explaining normality now? Everyone is opened? Yes. Any confirmation?
Yes, ma'am.
Yes. So friends, now to check the normality of your data, firstly, suppose I am considering here income is available, right? I want to check whether my income is normally distributed or not. Here I want to clear you one thing. Generally, when we talk about normality, you need to check the normality of the continuous variable or numeric or quantitative variable, right? So you can make a note in your notebook that when we are having the quantitative variable or numeric variable, in that case we need to go for the normality checking of the data, right? So for the purpose, I am taking here the income variable. Now you need to go to the analyze menu, then you can go to the descriptive statistics, and then here you can go to the explore. Is it fine? Analyze, descriptive statistics, and then explore. Is it fine? May I press explore button? Option. Yes. So now I have opened the explore option, explore descriptive, explore box I have got here. Now what I need to do, I need to check here. My variable name was this income, household income in thousands, right? So I'm shifting this variable to the dependent list box. This is all you need to do. Only shift your first one variable to the dependent list box. Then you need to go to the statistics button. Here you can find by default descriptives is selected by SPSS. So you do not need to change anything here. We will go with the by default option, and then you can press continue. Then you can go to the plots. In the plots, in the box plot, you can see factor levels together. So as we have not passed any factor here, you can see factor list. We have not passed anything in the factor. So whatever is the by default setting, we can go with that. Under the descriptive, you need to uncheck the stem and leaf, as it is now little older method. We will go with the histogram. And in the next option, you need to select the normality plots with test. Done. This is all you need to do here. Is it fine? May I press continue?
Yes, sir.
Yes, ma'am.
Yes.
Ma'am,
Now,
could you please repeat it once again?
from where?
From the plots option.
Plot option. Okay, you can click on the button, then you can come to the box plot. Here under the first option box plot, you can see as we have not sent or we have not forwarded any variable under the factor list. So what is the by default option? You can go with that. Even if you are passing anything in this, even then you can go with the by default option, that is factor labeled together, right? Then coming under the descriptive, by default stem and leaf is checked by the SPSS. So I suggested you that this is a little older method. You can uncheck that and you can check on the histogram. And then you can go to the normality plots with test. This box you need to check, and then you can press continue. Is it fine? May I press continue?
Yes, ma'am. Thank you, ma'am.
Yeah. And then you can go to the options also. Also, you do not need to check or touch anything here. You need to only see missing value, excluded cases list wise. So although there is no missing values in the data, so if even there would be some missing value, it will remove them case wise. Case wise means row wise, right? So you can press continue, and then only you need to press OK. You need to check here. There should be both options checked in the display. We want to see statistics and plots both. If you want to specifically want to see the statistics, you can check this also. If you want to see the plots only, you can check this also. But I want to see both the things, so I have done the I'm going with the by default option, and then you can press OK to generate the outputs. So is it fine? May I continue with this?
Yes, ma'am.
Yes, ma'am.
Yes. So now what you need to do? You need to see your output now, right? So here in the output, you can check we are getting the first table as a case processing summary table. In that, we are seeing that we are having total 850 households data available, right? There is no missing value in the data. So whatever are the valid cases, they are becoming your total cases, right? Coming to the next table named with the descriptives. Here you need to pay attention. You need to check the mean income of the households. It is 46.6753. Maybe it can be in thousand or maybe in lakhs or something, right? Coming to the next, 95% confidence interval for mean, upper and lower bound. It is 44.0805 and 49.2701. So the meaning is that if I am picking the other sample from the same population, so whatever sample I will pick and I'll calculate the mean of that income. So the mean will fall in that in this particular range. So this is the meaning of 95% confidence interval for me. Again, I'll repeat for you. If you are selecting any other sample from the same population, and if you are calculating the mean income for the population for the sample, so the mean will fall in this particular range. This is the meaning of this 95% confidence interval. Coming to next, 5% trimmed mean. 5% trimmed mean indicates us that after removing the 5% outliers from both the sides, from the upper and the lower side. As I have shown you the box plot, you can understand this thing. Maybe outliers can be present at any of the tail, maybe at the upper tail or at the lower tail or at the right tail or at the left tail. So from if the outliers are available at both the end or at both the tails, so in that case, 5% meaning is 5% from both the sides. We will remove the data, and that way this is telling us the mean value of the income. It is 41.5157. Median income is 35. Variance is 1485.567. Standard deviation of income is 38.54. Minimum of the income is 13. Maximum of the income is 446. Range is 433. I think those who are knowing statistics, they are knowing the meaning of formula for range is maximum minus minimum. So when you will subtract 446 and minus means when you subtract 13 from 446, you will get 433. Interquartile range is 32. Interquartile range is Q3 minus Q1. Third quartile minus first quartile will give you this 32. Skewness figure is 3.701. Kurtosis is coming as 22.486. So now, before proceeding to the graphs, I want to ask you, can I say that income is normally distributed here?
No, ma'am.
Okay, ma'am, may I know the reason why you are saying no?
Because the value has to be below 3. It has exact normality is 0, but we can take maximum up to +3 to -3 to +3.
Very good. May I know the name, ma'am?
Ma'am, this is Dr. Girija. I'm a
Oh.
fan of you who requested for this FDP for SPSS to the insurance.
Okay. Thank you, Girija, ma'am. Thank you.
Welcome,
Okay,
ma'am.
yeah. So, ma'am is very correct here. That here, if I am looking at the skewness and kurtosis value, as I have explained you in the PPTs, that usually the acceptable range is -2 to +2 or -3 to +3. If it is coming beyond these two figures, that way we can say that data is not normally distributed. Apart from that, I have told you one more thing, that mean, median and mode should be equal. Although it is not, mode is not coming, so maybe we can look at the mean and median. And again, we looking at the mean and median, we can say that these are not similar, or they are not even very far or very close to each other also either, right? So that way, also looking at the mean and median, we can conclude that income is not normally distributed. Now, the next method is of the numeric. In the numeric method, I have shown you the Kolmogorov-Smirnov method and the Sapir-Whorf test. Usually for the small sample size, we are reporting the Sapir-Whorf test, and for the larger sample, we are reporting the Kolmogorov-Smirnov test. So as the sample size is around 850 something, so I suggest you we will go with the Sapir-Whorf test. And for the Sapir-Whorf test, if you are making your note, I am telling you to write the hypothesis for Sapir-Whorf test. So may I? Are you ready to note it down?
Yes.
Yeah, you can note down the Shapirovil's test null hypothesis would be variable is not normally distributed. Sorry, variable is normally distributed. I hope you have written variable is normally distributed would be your null hypothesis. Note it
Yes.
down.
Yes,
Yeah.
ma'am.
Now we will see the interpretation here. So here significant value, this is the p value, right? So this value is stating the figure is coming as 0.000. So this is less than 0.05. As you, if you have paid attention, I have shown you the first button is statistics button. In that descriptives was by default selected, and there it was written confidence interval was 95%. So confidence interval was 95%. That means level of significance would be 5%. So we are comparing our value with the 5%. That is 0.05, right? So here we can see significant value is 0.000, which is less than 0.05. So can any one of you tell me if p value is less than 0.05? In that case, what we need to do?
Do not accept null hypothesis.
Yes, we are not, we are very good, very good. Thank you, everyone. So we are not going to accept the null hypothesis. And here a null hypothesis is saying that variable is normally distributed, means income is normally distributed. So we are rejecting it and we are concluding that income is not normally distributed. So again, it is supporting our previous results also. Is it okay? May we proceed further? Yes. Coming to the next part in histogram, I think looking at the histogram, it is quite clear that income is positively skewed, right?
Yes, ma'am.
Now, if you want to put here a bell-shaped curve, so those who are performing, they can see I am double clicking on this histogram area. After double clicking, I am getting here a chart editor. In this chart editor, you can see there is one bar is coming. In that, I am getting here a distribution curve, right? So you need to only click on this particular curve, and that way properties box will open. By default, you can check normal distribution is by default checked. I am okay with this. I'm closing this. You can see this particular curve is coming on my histogram. I can close the chart editor and I can see the same bell-shaped curve on my histogram. And that way you can check. Again, it is indicating that my right tail is greater than my left tail. So that way I can conclude that the income is positively skewed, right? That means there are very less number of people, those who are getting a higher income or those who are having a higher income, right? Because as at the right hand side, we are increasing the data points. So we are increasing the points, right? So that way there are very less number of people, those who are drawing or those who are having a good income. Most of the people are having the income which is less than to this particular mean value, that is 46 or something, right? Is it okay?
Yes, ma'am.
Yeah. Coming to the down, you can see QQ plot is again saying the same thing as I have shown you in the PPTs. It is indicating us that our tails are heavy, right? So that way again we can conclude that this particular graph is showing us, QQ plot is showing us that the income is positively skewed, right? Now, this detrended normal QQ plot, you do not need to report in your research papers. You can skip it. You can come to the main thing, that is the box plot. Box plot is indicating, you can see this is the median value. Once we will increase the line, it is coming somewhere here. So I think median is less than 50 or something, right? Similarly, you can find there are so many outliers we are getting at the right hand side, right? You can see some of the outliers are coming as circles, some of the outliers are coming as the asterisk sign also, right? So circles means these are not a significant outliers, but asterisks are significant outliers. Significant outliers means they will definitely impact your output or results, right? So you need to take a call whether you want to remove them from your study or not. So here you can see there are very where it means various asterisks we are getting, right? So this would be totally a call of a researcher, how many data points he or she wants to remove from his or her study, right? So suppose I am coming here, when I am coming here, I need to double click on the same thing, right? So chart editor will open. Now you can see, once I will click on any particular asterisk, that would be selected, right? Once I will I'll right click on this, you can see the option is coming as go to case, right? So once I will click on go to case, it will send me to the particular case, right? It is showing me that this highlighted case is that case which is the very extreme point of my research or of my data, right? So that would be your call whether you want to remove it or not. Is it fine?
Yes, ma'am.
Yes. So I think this is all for the day from my side in case of reliability and normality. Now the platform is open for all of you. If you have any questions, you can ask me. I'm ready to answer.
Thank you, ma'am Chanchala. So nicely you presented. Very easy to understand.
Thank you so much, sir.
I was reminded of my statistical classes which I learned during my MBA and MCOM and all.
Okay, that's
Thanks a
great.
lot.
Thank you,
very nice.
Prakash sir. Thank
This
you.
courtesies and all we have done long time back. After getting into finance, we have not got into this mostly, but it's very nice. It's very interesting. Thank you very much. Once again, my hearty congratulations to you. Thank you.
Thank you, thank you so much, sir. Yes, anyone else? If you have any queries, you can ask me. If not, so I'll share the poll with all of you that you can answer.
Can we
Any
go
queries?
for a poll today as well?
Yeah. I think we usually we are not using or I'm not practicing this thing in my previous FDPs, but I think as we are not what I can say, as many of you are not even giving the answers to these polls, but I just suggest, because there is nothing harm to answer the polls. It will only make you clear whether how much you have understood from the particular sessions, right? So
Yes,
I
ma'am.
have launched the first poll for all of you. You can see, probably it would be visible. You can go to the activities and find the poll. Poll number 1 got the 4 responses. Okay, very good. I expect everyone to please give the answers to these polls to check just how much you have grasped from this particular session. 7 votes. Very good. 10 so far. Very good. Impressive. Out of 56 participants, 10 people have responded. It's a good number. Good. $11, $12, $17. That's great. Suddenly, drastically number has changed from 11 to 17. Very good. So may I stop? 18 votes we have got. 19. Very good. May I stop the poll now? Can I share the next poll? Okay, I'm ending the poll. Yeah, thank you, Sugandha ma'am. First poll I have ended. The question was, internal consistency reliability can be checked by. Out of 19 votes, 12 have said Cronbach's alpha and 7 said correlation coefficient. So the answer is Cronbach's alpha. Very good. I am launching the next poll. Poll is active now. You can check the next poll. Okay, 11 votes so far. Thirteen votes, very good. Not bad. 14 votes, very good. Okay, I think maybe people are not much used to of this Google Meet. Probably they are not finding the polls. Maybe that is why they are not responding. 16 votes, very good. So I'm stopping the poll number 2 now. 17 votes we have got. 18, very good. Yeah. So I have stopped the poll number 2 also. Again, we got total 19 votes. The question was reliability is. So out of 19 votes, 16 goes to consistency of scale. This is the correct answer. 3 people said normality of the data. So extremely sorry for the remaining people. You need to please pay attention whatever I said to the during the session. Now I have launched the third poll, and after that there would be the last poll. Five votes, 7 votes, great. 9 votes, great. 11, very good. 13, all 14, all 14, all 15 for the same answer, very good. One I got for the second option, very good. 16 polls, okay, very good. 18 polls, very good. 18, very good. I'm stopping the poll number 3 also now. 19 votes, again we got 20 votes this time we got for the poll number 3. So the question was for perfect normal data. Out of 21 votes, 17 goes to mean equals to median equals to mode. This is the correct answer. 3 people have given mean is greater than median and median is greater than mode, and 1 vote goes to mean is less than median, median is less than mode. So the correct answer is all 3 should be equal for the perfect normal data. Now the last poll I am launching for all of you. It is live. The last poll is live now. Very good. We got 16 votes so far. Very good. 19, very good. 20, very good. So I'm stopping the last poll also. Ending the poll number 4th. So we received 20 votes for poll number 4. The question was the perfect normally distributed data. For perfect normally distributed data, the mean skewness should be. So the correct answer is skewness should be 0. 13 vote goes to the correct answer. Few people has given answer to -1 to 1, -2 to 2, and someone has given answer to -3 to 3. Right? So for perfect normally distributed data, skewness should be 0. Okay, so I think this is all from my side for the day. I hope there is no more queries for our day. So can we stop today's session?
Ma'am, I wanted to request one. Ma'am, it was not easy for me to understand. Is there any disturbance in my voice, ma'am?
Sorry?
Ma'am, it was not easy for me to understand statistics, but I'm very much motivated to learn. You are teaching in a very good way, ma'am. So,
Okay.
ma'am, can we get some PDF kind of thing or something so that we can practice? Because some of the things I'm missing, like how to do means which some of the things you are providing in the sheet and some sample kind of things and like exercises. And I wanted to do it again. So can I get it, ma'am?
The problem is that, ma'am, for that I need to prepare all these things because these all things I have not prepared in advance, as no one
Yes,
has
ma'am.
still date asked me for the same. So the
Yeah.
thing is, even I need to prepare that.
Yes,
So
ma'am.
yes.
some flowchart kind of like from analyze we need to go to scale and then reliability analysis. and-
Shraddha ma'am, I think problem is that once I'm explaining you that, I ask you to note down these steps, because sometimes it is little hard for me to prepare, because I'm a teacher also, I'm a faculty
Yes,
also in a college, and right now NBA
Mhm.
process is going on in the college. So I have to prepare lots of documents in the college. Maybe possible, maybe it is not much easier for me to do these things right now. So I just only suggest you, whatever I'm discussing during the session, you please note it down, or maybe we can connect in the future or somewhere if after the NBA process in the July, and if I'll get time, and if we will be in a touch, so probably I'll do that for you and we'll share that. But for the timing, it would be little difficult for me to this.
Yeah, I'm sure it's difficult.
Yeah.
I know, ma'am.
Yeah,
Quite
actually problem is
difficult,
an NBA process is going on in our college, and the audit is pending in the month of July. 24th and 25th is the date.
Okay, ma'am. Okay, fine. Thank you, ma'am.
Yeah, yeah. Yes, ma'am, I'm sharing my mail ID. Okay, wait a minute. Yeah, I have posted my mail ID in a group for you, ma'am.
Thank you, ma'am.
Yeah, thank you. So I think it is all for the day. Thank you everyone for your patience listening to me and coping up with me for the entire session. Thank you so much. We will meet again tomorrow with the next session. Okay, thank you.
Thank you so much, ma'am.
Thank you, ma'am.
Yes, thank you everyone.
Thank you, ma'am.
Thank you, Lata ma'am. Thank you. Yogi sir, I think we can stop the meeting. Thank you.